All right, folks. Might still be some people logging in, but we are going to go ahead and get started. So thank you guys very much for joining us for the ICM517A Surge Protection Device webinar. And this is the industry's most robust surge protection device, hands down. We'll get to all that, but redesigned. It's in this NEMA metal enclosure, and it's just an awesome device. I don't know if someone can help me as far as admitting all that show up. I get those notifications here, and I'm admitting people, but I know there's an admit all. I couldn't find it.
Not a problem.
Thank you. So let's go ahead and get started here. The ICM517A surge protection device. This is a type 2 surge protection device. We'll talk about that a little bit, difference between a type 1 and a type 2. But why use surge protection? This is a huge growth segment in our industry, as most of you probably know. We've got some competitors out there. Everybody is making inroads with surge protection devices because dirty power is becoming more common every day. There's so much pressure on the grid. We want to electrify everything, and it's we're not really set up to deal with the demands that are being put on the grid. So surge protection provides a low-cost insurance policy. Transient surges are a rapid event that can cause just instantaneous damage and failure to expensive equipment. So it's a really low-cost way to protect that equipment from harmful transient surges. Inverter circuit boards, very expensive and costly to change. We all know this. They're hundreds of dollars, and it's a half a day change out. So even if you're doing something under warranty, the opportunity cost is a killer. You could be out on other jobs, doing other work, making additional money instead of a callback type situation. Extends the life of the equipment. Any small surges and things that our devices is able to absorb and dissipate, could do extensive harm to equipment. And it prevents callbacks. Keeps everything running smoothly. Callbacks are a very expensive proposition for contractors. So what is a transient power surge? Transient spikes or surges are peaks in voltage that are extremely high in amplitude, and they're measured in nanoseconds. This is a very, very rapid event. Lightning strikes are one of the most common causes of transient spikes. Anybody that lives in Florida will tell you that. There's other states also that have a lot of lightning activity and that type of thing, and it's become a standard in most of those places. Contractors do not want to have to go back out and fix things. You have happier end user customers in the long run, and it's just a smart policy to implement. And where do spikes come from? They come from a variety of sources: lightning strikes, power outages and recoveries, down power lines, a number of different reasons for that. Startup or shutdown of large equipment in some of these manufacturing facilities. They have such high amp draw that when they shut down, they can, that voltage has to go somewhere, and it goes down the line and can cause actually spikes in equipment downstream from it. Equipment failures, short circuits, whole variety of things that can happen. And just a quick overview of how power is generated and pushed downstream. And there can be issues that happen in any phase of this energy chain that can cause spikes and irreparable damage. But power generation stations, and there's a variety of different ways they do that, from hydroelectric. Now we've got wind, solar, a lot of different ways to generate power. And they actually have to step power up at that point so that it can travel long distances across the countryside. You see the big metal power poles out there across the country landscape, sending power from one city to the next. They need extremely high voltage so it can travel those long distances. Then it comes into substation where it's transmitted downstream to industry. First, we've got industry in big industrial complexes typically run on 600 volts. And then it'll go through another substation, bust it down from there to send 460 to our commercial facilities. So any commercial type applications that our HVAC people are working on typically will fall in that 208, 230, 460, a lot of times three-phase power. And then it'll go through another substation where it comes to your residential areas. And it comes in as 230 volt, but it goes into a residential panel, and they break those apart into 115 and 115. So it goes into the panel. They refer to it as split phase. There's two independent bus bars that are each 115 volt. And so for your lights and your power outlets and so on, they'll just use one breaker that contacts one of those bus bars. If they want 230 volt, they have a dual breaker, a two-pole breaker that will contact both bus bars. And that's how you get your 230 for your air conditioning equipment, dryer, oven, things of that nature. And a lot of things can happen in that power chain. You can have a storm that takes down tree limbs and falls across a power line. You can have transformers that blow up, cars hit a power pole, a variety of things, and even problems within the transmission system itself that can send those problems down the line. This is a slide from the three-phase presentation that we do, but applies here as well. And it's basically, we've all seen these transformers and stuff on power poles outside, and we've seen these devices that are hanging off the sides of these things. And what this device is here on the left, and then is also shown in a drawing image here on the right, it is actually a surge protection device. So it's got its fin to dissipate heat, but also has these MOVs inside, which is a metal oxide varistor. And that's a semiconductor that's sensitive to voltage. So when excess voltage hits these MOVs, it actually, at normal voltage, there's zero resistance at normal voltage. At higher voltage, the MOVs will draw that excess heat internally to the MOV and try to dissipate that heat off. They're filled with zinc metal oxide grains, and zinc metal oxide has real good heat dissipation properties, so it'll absorb that heat and then try to dissipate it away. That's a very large scale version of what we do with our surge devices. We'll show you here in a sec. But why do you need it? Well, because impulsive transient surges are such a rapid event that line monitors and other types of devices won't even see them. It's a unique type of event, and surge protection devices using TMOVs are the best way to absorb that excess energy and try and dissipate it away as heat. Impulsive transient surges are measured in nanoseconds. And nanosecond, we've got a little description here, but it's a unit of time measurement that represents 1/1000th of a second. 1/1000th of a second. So it's extremely short time frame. And that's why a line monitor, for example, doesn't look at things in nanoseconds. It needs a little more time to recognize that there is actually a problem. This is a unique event. It's a rapid, high energy, high heat type of event that takes a surge protection device to deal with it. Many homeowners, all of us, actually already use surge protection devices. We buy power strips, surge strips, for our computers and TVs and all of our devices at home that we value and don't want to have to replace. We put a surge protection strip on there, which has little MOVs in it and stuff that are designed to take those hits. They don't last forever. So if you have these things protecting your equipment and you've had one for 15 years, you should probably invest and buy a new one. But we protect that equipment. Why wouldn't we protect the most expensive piece of equipment in the house? Which is your HVAC system. What you're going to see inside those power strips and stuff are these little disc type MOVs. When they fail, they fail kind of catastrophically typically. And we use a TMOV, which is a thermally protected metal oxide variable resistor. That's a fancy term, but you can impress your friends if you commit it to memory. But TMOVs are the best type of device for handling these transient surges. What's inside our ICM517A is a bank of 10 TMOVs. You see them here on the right. And this thing will take multiple hits. We get asked all the time, is it one and done? No, it is not. This thing will take punishment for a long, long time. Typically, when that surge comes in internally, the TMOV is going to take the hit. It's going to absorb the heat. It's going to try and dissipate it off, and it may be able to do that, with no damage, and then continue to take hits, or it may even take a little damage, but still, though it's slightly degraded, can continue on to take more punishment. This device, our device, is unique in that it is cast aluminum. It's a robust cast aluminum NEMA 4 enclosure. And so it's riveted closed, it's tamper proof, and it is the most robust on the market. Highest surge suppression capacity allowed by UL. ICM alone has the highest allowable surge suppression capacity that is allowed by UL. Ours is double what the competition is. Max surge current 100,000 amps. Energy dissipation 1020 joules. If you like to look at things in those terms, I've got something that breaks it down here going forward. And as you know, ICM, based in Syracuse, New York, our claim to fame, proudly made in the USA. So what's inside the TMOV? And there's a bank of 10 in this device, and each one of these TMOVs operates independently and will take that hit. And if it's able to, without completely, degrading the TMOV, it will take those hits and dissipate that heat off. It's filled with zinc metal oxide grains, like I say, which have real good heat dissipation properties, and will dissipate that heat away. If it does not, and this is to simulate that some of those things got fused together, there was enough heat there to cause a little damage, and it fused some of those grains together. Well, it's slightly degraded, but there's plenty of zinc metal oxide grains left to continue to take punishment and take the hits until that thing is finally used up, and then it moves to the next TMOV. So you've got a bank of 10. So this thing will take punishment for a long, 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 long time. So value added in ours compared to some of the competition, it has that robust metal enclosure, which is really a secondary safety feature to contain high power surges. So unlike some of the competitive models, RSH50, a lot of people recognize the Rector Seal and the Intermatic KG3000. These are epoxy sealed plastic enclosures, which may present a greater risk of improper venting. So these things, when there's a catastrophic type of event, like let's say it's a really big surge that is capable of, really causing some damage to one of those TMOVs, that energy needs to go somewhere, and it needs to be able to vent and go somewhere. And I watched a video that one of our engineers has of one of these things blowing up, one of the plastic devices, and it's like a small bomb. It was shocking to me. I was like, oh my gosh. And So it's worth considering, like where is this thing mounted? And, do you want to take the additional risk should something catastrophic happen? This thing's in a metal enclosure that is going to be a secondary type of protection, explosion proof type of scenario. So, the other ones, the melting or blasting apart of the plastic, which is what I saw is crazy. This is just a better device all the way around. ICM517 has that max surge current, 100,000 amps single event, compared to only 50,000 for the competitive models single event. So twice the protection, at least, because there's other ways to look at it and consider it too. But just in raw numbers, twice the protection, and in a safer type enclosure. High quality TMOV technology to absorb and dissipate the surge multiple times. This is not a one and done surge protector. Applications far exceed these: air conditioners, heat pumps, ductless, commercial refrigeration, keep naming it, because the way these things wire in, you can put it on the panel, and type 2 will serve as protection for one breaker. So you could put it on your refrigerator, or maybe you have some big, TV, thing that you value, or maybe it's a sound system of some type, or any type of device that you want to protect. Refrigerator, those aren't cheap these days. You could put one of these on that breaker and protect your refrigerator. But it's designed for a single device or a single breaker, a type 2. Type 1 surge protection device can be used as whole panel protection. And we have those as well, the ICM518, and those are 200,000 amps. So they're twice the protection that the 517 is even.
I had to make a correction on that.
Okay.
I'm sorry, they are 100,000 as well. Where you get more protection with the 518 is the number of hits that it can take. The nominal discharge current on the 518 is 20,000. It's 20 kA nominal discharge current, rather than 5 kA of the 517A. But the total protection for a single hit is the same, 100,000 amps.
Okay.
Sorry about that.
But again, type 1, the 518 is a type 1 device, so it can be used as whole home, whole panel. And the 517 is designed for a single device or a single breaker. And that's where our guys use them. I mean, they're using it to protect a condenser. Typically, you'll see them under a disconnect box outside by the condenser, and that's the wiring diagram here on the right. So, just wires right into the existing disconnect. Super easy. L1, L2, and then and ground, and it can be used for 115 volt as well. You just tie the two black wires together in that instance. So let's see what we got here. Troubleshooting, nothing to it. Basically, it's got an LED indicator down here at the bottom. If the LED is lit, glowing green, you're protected. If it's not lit, it's time to change the device. So you're not going to fix anything internally inside this device. You're going to take it out and wire a new one in. Simple as that. And based on some of the feedback that I've received from our engineering department, that is a very rare occasion. No field service. Like I say, just replace the device. Warranty. We have a 3-year, $25,000 connected warranty, and all the information on this comes with the device, but it's printed right on the box. But also, you can go onto our ICM website anytime you want. Sell sheets, warranty information, installation guides, any of that type of thing. They're all right there on the ICM website. We also put QR codes on the box that this device comes in, and you can scan that and it'll take you right to that page. So you have all the support documents right there at your fingertips. Line monitors versus surge protection devices. And I'm throwing this in there because I think it's important to note that while the 517A is an awesome device, in my opinion, the best device out there in its class, it is a unique event. A surge like that is a unique event. So you're protected with these. I mean, you're well protected from those surge events. But what if you have a brownout? What if you have an undervoltage condition? A surge protection device, anyone's surge protection device, is not going to do anything for you in that circumstance. So line monitors are great. These over here, they protect equipment from prolonged and undervoltage conditions. But a line monitor is not a surge protector. Conversely, a surge protector is not a line monitor. So these are two different animals. They're two different events, but they really go hand in hand. So with the line monitors, you're able to monitor incoming voltage continuously. And what a line voltage monitor wants to see, it needs to see a condition over at least 1.5 waveforms. Now this is adjustable. You can have the interrogation period. You can extend that out if you like. So now it's even a longer period that it's going to look at the sine waves before it decides there's an actual condition and faults. But it must see a minimum of 1.5 waveforms or 25 milliseconds. So you see, line monitors are now monitoring things in milliseconds as opposed to nanoseconds, a billionth of a second for the surge devices. Now we're looking at things in milliseconds, 1,000th of a second. So you can see it's a longer period of time that this thing wants to see those waveforms, and it wants to know that there's a condition. So you might have one wave sine wave that goes a little high, but it might correct itself on the next cycle. So, or low, and it might correct itself in the next cycle. So you don't want this thing just dropping out all the time. That's a nuisance. That's going to get you a callback. You want it to interrogate responsibly, make sure that there's actually a problem there before it drops out. And it's a totally different way of looking at and protecting equipment from voltage anomalies. So you set your parameters for over under voltage. It protects against rapid short cycling, caused by power interruptions. True RMS voltage monitoring. That means it's like putting your meter on there. You got your field piece meter on there. It's reading the same way that would read. Adjustable voltage set point. You can calibrate it for that incoming voltage so that you can set your over under parameters, and then adjustable response time. How long are you going to let it interrogate before it actually shuts the system off? And it's got a 5-fault memory, which is really handy because then you can see if you're having a continued condition. Man, I've got the last 5 faults are all brownout, and that's going to do damage to my equipment. Well, now you might be able to, talk to the power company and say, hey, we've got a situation out here. Universal line voltage input. So it's, 80 to 300 VAC, heavy duty single pole, double throw relay output if necessary. And so the thing that's kind of nice about these from a competitive standpoint, they're essential for monitoring that brownout condition or those over voltage conditions, continuous over voltage condition, not a spike, but that continuous over voltage condition, which can, fry windings in the motors and stuff. Short cycle delay is important to prevent short cycling. And then, some of the competitor models don't have that feature. Clean digital display, precise digital controls. And, some might have potentiometer type knobs on there or something, which are not very accurate. These are, dead nuts accurate programming, eliminates any guesswork. And it's a passive device, so it wires in parallel with the line and breaks a control voltage to shut down a load. And I'll show you that real then you can also use that relay in there. So line voltage monitoring. You've got your incoming L1 and L2. Just hooks up to L1, L2. Obviously between the disconnect and the contactor, and then this circuit here is going to basically open the contactor coil if there's a problem. So the unit has determined there's a problem. Contactor coil opens, cuts power to the system. Pretty simple. Here's just a little more real world look at the wiring. So your L1, L2 come from the disconnect right here, and then continue on. And then your Y call is going to get broken across here, and the device is going to determine whether or not to send power to the contactor and pull it in. We also have surge protection devices in disconnects now. We've got a 30 amp fused and a 60 amp non-fused, and this is a good way to go as well. It offers the same protection as 517A and is pre-wired, so it makes life pretty easy. 517, should you have to change it, is very easy to change, which is a nice feature as well, and it can be used for multiple devices or on a single breaker and that type of thing. So let's see, any thoughts or questions on competitive models, on the device itself? We've got engineers on the phone to help us as well.
Hey,
I had a
Keith?
question.
Yeah.
Forgive me, I'm pretty new. The TMOVs you mentioned, there's roughly 10 of them in the 517. They don't share the load when a surge comes in. They take the surges one at a time.
No, they share them. They're wired
Okay.
together. They're wired together in parallel.
Okay. Oh, when he was explaining it, it sounded like they take it one at a time, and after the one fails, the job goes to the next one in line. That's not how it goes.
No, they're all in parallel, so they're taking it together. But what I think Keith was trying to get at is that when a MOV takes a hit, it doesn't necessarily consume the entire MOV at once. You know what I mean? It might just degrade it a little bit, and then over time, eventually the MOV might fail. But you still have other MOVs in there. But the way that these work is when the unit takes a hit, if one of those MOVs eventually fail completely, even though they're wired together, they have parallel wiring, but even though when that light will go out because it's across one leg of the line, that light will go out when you've sacrificed one or more of those MOVs. When you don't have full surge capacity of 100,000 amps anymore, but they could take multiple hits under 100,000 amps.
So to the question, I think a better way for me to state it is they'll share the load because they're wired in parallel. So if it's necessary, it'll spread across more than one TMOV, and then can dissipate excess heat in that way, right? Which is less catastrophic to the first one trying to take the full load. It will spread across to other TMOVs.
Right. Oh, those each, just so that you know, each one of those TMOVs is 10,000 amps rating each. So in order to get that 100,000 amps, you have to have all 10 of them in play.
Right.
Yeah.
Which is probably a rare occasion, but
correct.
Yeah. But
okay,
no,
thank you.
Great question, because that helps kind of clarify for me too how I should state that. I should definitely explain that, clarify that, and explain that a little better. So
no, I get it. I appreciate it.
Yeah.
Chris,
Hey,
you had
Johnny.
something? Yeah.
John, this is Matt with Danco out in Denver.
Oh, yeah.
I'm running across the Rector Seal product quite a bit, the RSH50. I have a comparison sheet and just wanted some clarification on a few points. Obviously, you got the better surge protection, got a better connected equipment warranty. Is there a difference between a TMOV and a TF MOV,
No,
which is what Rector Seal has?
no, that
Okay,
just means thermally fused. Thermally protected, thermally fused means the same thing.
gotcha.
Ours is just twice as good as the Rector Seal for several reasons. Number one, the Rector Seal sits outside, hanging off a device. It's a little small. People like it because it's small, but
Right.
the problem with it is that what Keith mentioned before, that's a plastic enclosure and it's epoxy sealed. Now, if somebody during their manufacturing process didn't get that epoxy just right, and it doesn't vent properly, it turns into a pipe bomb. You know what I mean? So with ours, you have a metal enclosure. The big thing about ours is that secondary safety feature of the robust metal enclosure. And that's going to contain any severe blast from a serious surge much better than plastic or being an exposed device that might be sitting outside your, like on your house or something like that. It's just a secondary safety that makes it a better, a more safe product. Plus, it's got twice the surge capability for a single event.
Perfect. Thank you.
Yep. Chris, you had a question. Your hand is raised.
Yeah, sorry, I had mute on still. No, I was just wondering, hearing about the 517A with, the enclosure, how it can be an additional safety protection with those large surge spikes. Do we have any kind of like a video that shows our competition with those same version of surge spikes? Maybe that can show how important our enclosure is to help, keep those systems protected. Do we have anything like that out there?
Video? I mean, I'm not exactly sure what type of video. Are you saying a video that explains why ours is better?
Like a comparison showing competition versus ours, how they would react in that same kind of, surge spike in that environment, essentially, is what I was asking.
Yeah,
Um,
I don't have that. I don't think there's anything like that
well,
we have.
I mentioned I made mention of the video that Eric showed me of one of those plastic ones blowing up, and I mean it was shocking to me. But I don't know if that's something, you know, is that something that you share? You know what I
Right.
mean? We'll have
I
to
agree.
sidebar on that to see
Yeah.
if it's appropriate to do that. Because
We don't want to bash the competition like that they're bad or they're we just want to show what benefits we have that are better.
right, exactly.
That makes sense. I was just curious.
That's okay. Any other questions? So you did a good job, Keith, as usual.
Or people are still asleep. I don't know. One or the other. All right. Well, hey, we always
John,
appreciate you
can you hear
guys.
me?
I can hear you.
Joining in, and John, thank you very much for your help. Always appreciated.
You're very welcome.
I have one more question if I can help or if I can ask.
Sure.
I've been hearing about the RSH50 on their gas discharge tube. And that's what people have been, I guess, talking about. I don't know the differences. I don't know if y'all do or not.
Yeah, the gas discharge tube is older technology.
Okay.
It's a secondary type of surge suppression after the TFMOVs. I don't know how much benefit that actually brings, but it's sort of like their kickback to our secondary safety of the box. You know what I mean? So they've got their little secondary safety too. You know what I mean? But
Yep.
it's I'm not sure the gas discharge tube is adding that much value, to be frankly honest with you. Ken, or Keith, do you know more a little bit about the gas discharge tube technology?
Eric explained it to me one time in pretty good detail, and like you said, it's an older technology, inferior to the TMOVs, really, and most people I think are hip to that. They're starting to use TMOVs and stuff in the surge devices, but I can't remember the details on that. Eric is not on here, I
No,
assume.
he's not here today, but basically what it is it uses some type of an inert gas to suppress the surge, arcing of the surge or something like that. It's just a little, it's just you could
It's a
consider it
little
just
gimmicky.
yeah, it's a little gimmicky. It's a little
Okay.
something extra as a secondary safety to the TMOV. The TMOV is the critical element. The gas discharge tube, very old technology they used to use in the old days, is when this was relatively new stuff. So it helps a little bit, but not anything really significant to make it a major selling point. That's why we didn't add it.
Yep. Awesome. I appreciate that.
Okay, Nick.
Hey, do you guys hear me? Hello?
Yep.
Yeah.
Hey, my name's Jake. Quick question. Is there any reason why I should ever then recommend an ICM518 as a Type 2 installation, like under the disconnect? Or in this case, would it always be the 517A that I should be pushing out?
Well, so a type 1 can always be used as a type 2, and not vice versa, right? So a 518 is going to offer you twice the protection that a 517 has. So if it's a larger, maybe it's a more commercial type application, something like that, you may have some concerns there. You could go with the 518. But from a price point standpoint and all that, I think that's why the 517 is, it's one of our flagship sellers, and price point does come into play a little bit, I think, between the two devices. So just personal preference.
May I add a little bit
Sure.
to that? So the reason why the price point's different, and I gotta just make a slight correction to Keith's statement. It's not twice the protection. I think that's just a misunderstanding. It's got a higher nominal discharge current rating. Now that means that it can take more hits than the ICM 517A, but the actual amperage protection for a single hit is 100,000 amps. Both now, the just to clarify that the ICM 517A has 10 MOVs in it, TMOVs in it that are rated at 10,000 amps apiece. So that's 100,000 amps. The 518 has 2 MOVs in it that are rated at 50,000 amps. So that's still 100,000, for a single head. The big difference of the 518 to the 517 is, number one, it's a type 1 rated device, which means it's a whole house surge protector. Number two, it also has a very high nominal discharge current rating, which is what Keith was kind of alluding to in some of his earlier slides, was that it's the highest nominal discharge rating that UL will test to. All right. So in other words, 20,000 amps is the highest nominal discharge current. And what that means is that it took a hit of 20,000 amps 15 times in a row before, and without degradation. All right. Without failing. So that means that, it's a very robust design, a very high quality TMOV. The TMOVs in the ICM 517 are very good. They're just not to the level of the 518. And that's what the difference in the price is for. They're different MOVs, TMOVs, and there's a little bit different technology in there, but it's also, both of them are top rated, top quality products. The 517 is a little more popular because it can be wired for both 120 and 240. Where right now we're marketing the 518 for the split phase, which is 240, because that's all you're going to need it for. Because people that are going to buy the 518 are going to, why wouldn't you put it whole house, put it on the main disconnect coming in on the mains, and then you protect your whole panel. So that it's just a different market, maybe more of the industrial electrical market, maybe more, if somebody's building a new home, they could put the 518 on, because they haven't put power to the building yet. Some people don't have the license or the ability to use the 518, right? Because you have to shut down the mains, so.
Yeah. There is a way to wire that load side below the main breaker by installing a dedicated breaker for the ICM518 that's contacting both bus bars, and we can help you with that if you want to discuss that a little bit further sidebar. But great devices, I mean, no question, and both would offer you, superior protection over competitive models and stuff. So, any other thoughts or questions? So, as always, you can go to the ICM website, look at our media library. There's tons of information in there, including videos, installation videos. We've got some loop videos that are good for store, store monitors, branch in the branch stores and stuff, where you can run little loops, and they're just short little loops, maybe a minute, or something, 2 minutes, that just show you the product. They show a picture of it, and then they give you bullet features and benefits, and it can help counter salespeople learn about the products and where they might fit, and so they can offer suggestions to contractors when they come in and have a problem in the field. They can direct them, hey, I know exactly what you need. You need an ICM517A or whatever the product may be. Product details, application guides, sell sheets, detailed product info, tons of help on the website. And then we're always here for you as well. Call us anytime, and look forward to seeing you on future webinars. We've got a lot of them coming up, and we're going to continue to go into detail about each of the products to just help everybody get up to speed and sell more ICM.
Is this is a great presentation, Keith? Is this going to be available also on our website? This particular presentation?
Yep, it's being recorded, and so we typically will put those out on the media library, and they'll also be out on YouTube.
Perfect.
All right. Well, thank you everybody for your time. We appreciate it very much, and look forward to seeing you on the next one.
Thanks,
Thank
Keith.
you. Have a good
All
day.
right, thank you.
Thank you.
All right, take care.